Hello and welcome to this next part of our tutorial for Julia. In the last part, we've seen how to write a basic function, how to read data from a CSV file into a data frame, and how to use this data to set up our deck. And obviously this is only partially useful because we only have this one deck, but we could edit this function to, for example, have multiple sets of cars. And this is the first thing that we'll do. We'll take this here, the file name, and remove it from here and give this a file name, and here a file name. What will now happen, I will now have to call the load deck, and it also tells me already by using the blue squiggly line here that it's not called correctly. If I override this and do this, it will still work. Why? You should probably wonder, maybe it should have a file name, but the thing is, if I have a look at load deck and I have it now highlighted without the parentheses, and if I execute this, it tells me generic function with two methods. And the reason for this is that we've not unloaded Julia since the last time, and we haven't resetted it. So the old function with no parameters is still available. So if I now close the Julia REPL here, and if I run everything up to here, we will now see that this fails because the load deck function that I've initially written is no longer available in memory, and it now tells me no method matching load deck. Closest candidates are matched any, so it has a parameter of the any type. And I can put this in here and this should work. And now, okay, the deck has 6 cars in total, and now we see that it returns this 6-card vector. But let's look back at the error message. We saw that the closest candidate is load deck any, and the reason for this is we don't specify a data type for file name. So we could, in theory, we could have written load deck false, because that's also a type of any, but it says no method matching CSV file bool, and it breaks as soon as we load in this case here, the CSV read boolean doesn't work. So it makes sense to make sure that we only have a string in here, and we can do this by putting 2 colons and a string. And if we now kill the Julia REPL and do all of this again, if I now run load deck false, it will tell me, no, this isn't possible. The closest candidate now is load deck string. So it's expecting a string. And this will tell me, okay, this might be a file name. And okay, this now works. We can now read our cars from the ourcars.csv file. And if we have a different CSV file with different values, we can basically call it using the load deck and the other file name. Okay, so loading the cards we have now already put into, I'm sorry for the scrolling that is so fast. Split the cards between the 2 players. We don't have 16 cards each, so at the moment they will probably just get 3 cards. We have the decks, and the decks are empty in the beginning. So what do we do here? Yes, we get a empty vector, which now contains 2 empty vectors. And then for the amount of players, we initialize cards count not defined. And this is the case because cards count we've created up here when we were counting the cards for the message here. And it makes sense, let's do like this, that this is not in global scope. We want this here. So let's see, cards count, we only need this here. So instead of cards count, we basically, how did we do it? We call length of deck. Length of all cards. This should now work. So we now go from 1 to length of all cards divide it by player count as an integer division and add an additional round for the last round and do all of this. And this now creates or sets up our dex variable so that we have a 2-element vector, and the first one has 3 cards and the other one has 3 cards, and they don't have overlapping cards. So what we do is we kind of create all of this here creates the player dex. So maybe we can wrap this, the splitting cards between 2 players, we should wrap this in a function. So we call this function deal cards, and at the beginning it does nothing. So let's move this end down all the way down here. So what it does now is we have this deal cards function, and if we call this deal cards, it does something. But if we now have a look at the dex variable, oh, it's still available because I haven't restarted Julia. Let's restart Julia. It's always helpful if you restructure something to make sure that it still works after restarting Julia. I highlight all of this, run it, and up to here it should work. And once it's done, no more cards to hand out. It played everything. If I now access dex, it says dex not defined. And the reason for this is scoping. The variable dex is created inside of this deal cards function in here. And this means it's only available inside of this function. Similar to loops, variables that are created inside of a function are only available inside of this function. And if we want to make it accessible, we have to return this variable at the end, dex. And then we can access it by, if we call it like this, and we do it like this, we then get access to this empty deck. And now we wonder, why is it empty? Didn't we assign all these cards here? Didn't we? So if I access the individual decks, it's now an empty set of cards. Why is that the case? The reason for that is that what happens is here we access this global variable all cards because it's outside of the scope, and we remove the cards, all cards, we delete from this all cards array, and now if I call this thing again, it sets up a new dex variable, but the all cards is no longer there. So we could do all cards is load, did we say load cards? Load deck. And we have to give it our cars.csv. And now it loads these all cards, and now this should assign, yeah, perfectly, the cards into the individual decks. But this is kind of strange. The behavior of this card depends on what I've been doing before that, and that is something in programming that we don't want. It should not depend, the result of a function should not depend on global state. That is because we never know, if I do this again, now I get empty cards because the all cards has been emptied by the previous function. So one thing that we could do is if we want to keep the feature sets the same, we should give this the parameter all cards. So what we now have is if we do deal cards and give it the all cards vector, it still returns, oh, I have to reload the function. So now we have 2 functions. It now returns the empty thing because the all cards variable is not assigned. And we can do this again, load deck, our cars CSV. By the way, if you're wondering how I'm typing so fast, as soon as the editor assumes the right thing that I can do, I just press the tab key on my keyboard and that auto-completes for me in a well-working manner. So if I do this, it works now. And if I do it again, it doesn't work. So that is a behavior we don't want. If this parameter, the all cards variable, is edited by the function, we should at least put an exclamation point here. So the deal cards function should have an exclamation point if it changes the all cards. So now this would be the right way of writing this, and we get this. But still, it feels a little bit odd that we have to load the cars again. We should probably do it in a way that it doesn't change the cards. It just generates 2 decks from our all cards. We only edited the all cards set here to make sure that we don't use the card over and over again. So we don't want the deal cards to actually change the all cards. It should stay the same. And how do we do this? So let's do the loop, give each player 1 random card. We don't actually, this is old code. We don't need this anymore. Let's remove this. Let's do it like this. So this is the return type. We don't do 16 cards each, so we just split the cards from all cards between the 2 players. Yeah, we will have 2 players at the moment. So decks, we create this set of decks and we set them up player count. So it seems to me that player count could be something that we give this function. So if we do player count, we could do deal cards 2, and this will give me 2 decks. So if I do this, I should now, if I do this, I get 2 decks. But if I do 3, I should get 3 decks. Perfect, that works. That was easy. So the player count variable already, if I put this in here, already works. Let's add some documentation code here. Split the all cards, split the deck given in the first parameter between the players. Okay, so this is where we set up the empty decks, set up empty decks. And here we want to assign the cards for the individual rounds. And in this case, I'm wondering, if length doesn't change the all cards, but the deletion does. So how about we do the following? We call this the function cards, and this is a stupid terminology. And what we do is we copy all cards. So doing this creates a copy of this variable all cards, which is currently empty, and it doesn't change this if we now copy the word function cards and put this everywhere where we used all cards. And now we create a copy from all cards, put this in our variable function cards, create a copy. And if we now override this, we can now load our cards in our all cards. This is the basic card deck. And now we can draw the individual decks. And now we have 2 decks, but we can do it again. And we can do it again. And they are always given to the player, to the 2 players, or they're given to 3 players. We can even do 4 players. And we can, I think we can go up to 6 players. Yeah, so we now have 6 players. Every one of them has 1 card, but we don't have a player logic for 6 players. So let's stick with 2 players. So we only need to load the cards once. We don't do this here. Let's do it down there. We first write all the functions that we have. And maybe all of this can go down here as well. And I'm telling you why in a second. So the way that it's organized is up here are the functions, and the functions are somewhat independent because they are executed to make them available, but they don't actually, let's remove this comment here because it's empty. So the car structure is there, this function is there, this function is there, and now if we do all of this, game has ended. Oh, we do have the variable player count equals 2, so we could put this in here as well. It sounds like we're just using the same player count again, But that's not true. This player count variable here is a local variable inside of this function. The deal cards, by the way, should rely on the all cards data type. And the player count, that should be a number. So we could say integer. Integer is a whole number because we don't want 2.5 players. We only want 2, 3, 4, and so on. We could even do int 64, which will determine the size. But if we just do integer, it will just match the size of the number. By size, I mean how large the value can be that is stored in this variable. If I just do integer, it uses the one that's native to the machine that we're working on. So it uses an int 32 if we're on a 32-bit machine and an int 64 if we're on a 64-bit machine. So let's do all of this. This should work. This should work, and this should work. The deal all cards now works. We could even say that all cards should be a vector of car. So this is a little bit clearer. So we say vector of car. So we can only deal a set of cars in this deal cards. This should not change anything. And this works. Now we can deal the cards over and over again. Interestingly, we always get, do we always get the same result? So the first player is BMX5. Do we have randomness in this function, by the way? So dec remaining length, println. Oh yeah, we do. This is randomized. So we should split randomly split. So we know that this function does this randomly. So we know that we get randomness in here. One of the things with randomness is, where is the random function here? Random is that it can be, randomness on a computer is not true randomness. And the reason for that is that computers, they work deterministically. So they produce the same randomness every time. So let me quickly demonstrate this down here. If I do rand, I get a random number, 2, 1, 2, 3, 5, and it's different every time. But there is a way of giving it a random seed that will make sure it's unpredictable. So I don't know what is the next number, but it behaves the same if I run it from start to finish. And this is helpful for reproducibility of experiments. And we can do this by doing, I think, random seed. Is that the way? Or no, this is not how it's done. I think we have to give it a random number generator. And typically we give this the name RNG. And from this, we need the random package. So let's add the random package, add random. And if we add random, we should call it up here as well, using random. And let's go back all the way down, RNG. So from the random package, wait, I haven't loaded it yet, so let's load it here, okay. Close the package editor, the package manager. And here I can now do random. And there are a lot of different types of random number generators, and one that is often used is the Xoshiro random number generator. If you're curious about what different random number generators do, please feel free to have a look. If I now submit or add this RNG parameter to the random function, it will use this to determine the random number. So if I do this, it will always be different. But I can initialize this by giving it a seed, for example, giving it a 1. And now I get 0.0733. And if I do these two functions again, I get the same exact number. So this guarantees that the first call of random with this RNG is always the same. Obviously, I cannot predict what is the next number here. There's no way of predicting what's the next in line, unless you've done the experiment, obviously. But this number here determines, and I cannot determine what is the outcome here, by looking at the numbers. So 756, I don't know what this means for the first number. It's 00.8. But even if I increase it by 1, 757, there is no way of, okay, this is a big number now. The random numbers go from 0 to 1, and this is 0.98. And there's no way to infer from this number what is going to be the first result of random. And there's no way of telling what is the next from the first, and so on. So this is a way of making sure that randomness is reproducible. And we should do this up here. We initialize our random number generator, and in here we can put any number that we like, and I'll just keep it at 1. Obviously 1 is not the most secret one, so people have probably explored the randomness of this random seed, but since this is not about secrecy, but it's about reproducibility, we just keep it like this. And now, whenever we do a random, like here, we first give it the RNG argument. So if I have all the cards set up, and I do this again, it should now always, the Mustang, the Toyota, and the Chevrolet. So let's kill the Julia REPL and do all of this again. It should give me, even if I don't restart now, it should always be the same. Mustang, Toyota, Chevrolet. If I do it again, Mustang, Toyota, Chevrolet. It's always the same. If I deal the cards again, so the second round, that one's going to be different. That one is Toyota, BMW, Chevrolet. So these are not the same. But the first instance of this is always the same result. And now I've packaged the dealing of cards into this one function. The next thing we need to do is package the actual playing into a function. And then by calling these two functions after another, we can repeatedly explore the result. So let's see, this actually we don't need to print the decks here. We decide who goes first. This we can actually do even before we have decks. This is where we can, we have randomness here, so we should give it RNG as well. So this determines who goes first, and it will always be the same because we don't adapt our random number generator. Okay, let's wrap the last function, which is the main game, into a function. So let's call this function run game. So how do we do this? Rounds played is actually something we want to do outside of run game. Or no, it's actually inside of, it's how many rounds are played inside of a single game. And let's move, the easiest way to do this is move this end all the way down. And this includes here, all of this. So let's see what happens. If I do the run game function, I can now do run game. And rounds played is not defined. Why is rounds played not defined? It's here. Rounds played is not defined. Oh, because it says global, and global means on the top. So it's outside of run game, which is no longer the case because it's now inside of this local function. So we should remove the global and see if it works. Active player not defined. And this is interesting. So the active player is something that we've defined up here. So maybe, does the active player change? Oh yeah, the access is, So let's say there is a local variable called active player. It's no longer global. And we set it up here, active player. Let's say it starts with 1. And now it works, and it gives me the result. Player 1, player 1, player 1. So now player 1 always wins the game because the decks are never shuffled. And one thing we could do is We could, this active player is randomly determined outside of here. So how about we rename this one here? And this variable shouldn't be active player, but it should be player goes first. And we can put this variable as a parameter in run game. It's an integer. And this variable should then be put in here. So we decide the active player becomes the player goes first. And if we initialize this randomly, then the run game function, the run game function now actually requires this. So player goes first. It can now, we can see if player 1 goes first, player 1 wins. If player 2 goes first, he still wins the game. So this is how we could do this now. The run, let's move the run game function all the way above our main code. Is that where we want to be? Yeah. So now this is above, and now this is player goes first. So this is now our main program. Player 2 won the game, player 2. And I can rerun this. And in this case, player 2 always wins the game. What we only need, maybe let's do all of this and put this here. Actually, all of this is just initialization. And this is where the players get new cards, and then we run the game. So this is actually the game, where we randomize who plays, and then we play the game. And we can now player 2, player 1, player 2, player 1, player 1, player 2. And what this does now, it we see now who of this player wins. And obviously we want to track who wins, and we want to see if one of the strategies is superior. So let's do the following. We have a variable called wins, and that should be an array of 0, 0. So in the beginning, no one wins. And let's have a look. The run game should probably return who wins the game. So here we should do return 1, and here we should do return 2. So all of this returns who wins. If, yeah, this function only works. Let's do a comment here and explain this function. Play the game with global variables. What do we need? We need dex, because we don't give it to the function. We need cards on table is only something that we do inside. Active player is local variable. And both cards go to the winner's dex bottom. Do we? Yeah, we do that here. Where do we push the cards back? Did I remove something accidentally? Let's see if this still works. So the run game function now returns 1 and 2. And if I do this, it should, yeah, player 2 won the game. Player 2 won the game. Player 2. Okay, this seems to work. So what we want to do now is we want to play this for a couple of rounds. Let's say we want to play this 100 times. And we put this here. And we say winner. And then for wins of winner, we do plus equals 1. Oh, so for I in. So we do this all to 0. And we do 100 rounds. And now let's see. So player 2 won 78 times, while player 1 won 22 times. If we do this again, let's see what happens now. 20 times, 80 times. 18 times, 82 times. We can do it a lot more. Let's say 1,000 games. And this takes a while. And we see it's about 80% of the time player 2 wins and 20% of the time player 1 wins. And what we see is 1,000 of these simulations, they take a while. And the question is, why does it take so long? These functions shouldn't be that hard, right? What is it that takes long? And one thing that we can do to determine what takes a long time is we can see by calling the add_time macro. This is a feature of Julia. This is something that adds code for us, deal cards, all. So basically, I'll show you what I do here. I copy this here, and I do a add time before that. And what this does is it tells me this takes 0.01228 seconds. And if I do it again, 0.01. So this doesn't take too long. Let's see if the run game, how long this takes. And this takes 0.001. So we should be able to do 1,000 per second. How long did we take this? 21, 22, 23. It took 3 seconds. So this took longer. And the reason why is not as obvious. Wow, this was only 16 to 1,600 to 355. The reason for this is that what takes a lot of time is printing things to the command line. Printing things here takes a long time. So whenever we do print, this will take a long time. And we can, in theory, if we just comment this out and comment this out, because we get the return, right? We see what's going on. And let's see if we do all of this again. And oh, the deck handing out. We can measure all of this as well. We can do add time for all of this. And we see this now takes 1.9 seconds. Where do we also print? We print here with the deck size. Let's comment all of this out. Is there any more printing? Let's do all of this again. And let's see how long, in 1.9 seconds to beat. Oh, it's 0.04 seconds. So we drastically improved the speed of this. Let's do 10,000 rounds. It only takes 0.05, so that doesn't even change anything. 100,000 runs. That actually took half a second. So 100,000 takes half a second, obviously because it takes a lot of memory. But this is the performance that we get without a lot of optimization. 100,000 runs if we don't see the messages. And we see the winner in most cases. This is now, oh, because I didn't reset it. Let's reset it at the beginning and do this again. And now we see it's about 80% of the time player 2 wins and 20% of the time, 18% in this case, player 1 wins. And the reason for this is obvious. Player 2 plays random. What does player 1 do? I forgot, always picks top speed. Player 2, second player picks randomly. Actually, we didn't implement this yet, so this is something that we still need to do. It just returns to the other player. So let's say to do, that is something we should do in the next round, that he actually picks randomly. But this just means that player 1 who picks top speed only is right 1/5 of the time, and the other player is right 4/5 of the time. Independently of how the decks are distributed. And the last thing for this video that I want to show you is, okay, we've now removed all the input, but the output to the console, but maybe we want that. We want to see who wins. And how do we do this? If we do it only for this function here, run game, we can give it a parameter, and let's call this parameter debug, and we can actually initialize it to being false. So the run game function, I just do run game here to test what I've been doing. Run game, what does it require? Player goes first in debug. Let's also give this an default value. If I tell, like, per default, player 1 goes first. I mean, so I don't have to, it says player 2 wins, player 2 wins, player 2 wins. Okay, this works. But what does the debug thing do? It doesn't do anything. We just named it debug. And if we now do 1 and true, this starts with player 1 and gives the debug flag. But that doesn't do anything, right? It doesn't do anything. What we can do with debug is whenever we have a print such as this, we can do debug and print. And now you're wondering, why should that do something? What this does, and it's a trick that you often use in Julia, is to determine whether this expression is true, it first evaluates, because it's an AND expression, if the first expression is true. And if it doesn't, if this is not true, it just cancels because it knows that all of this is false and it just returns false. It returns this to nowhere, it's not saved anywhere, so it's just lost. But what the debug AND thing does, it only calls the print command if debug is true. So if I now refresh the function, I should now, let's do false. Let's do true. Wait, that didn't work. What happened? Debug is false. Debug and println. Wait, let's do it differently. The normal way would be if debug is true, we want this printed. Let's see, player 1. Oh, because player 1 never won. So yeah, it worked, but we never saw that he won. So let's put this here again. Debug and player 2 won. So this should now work. It doesn't. What's going on? Debug if debug. Let's see if this works. Why is there no output? Wait, let me restart Julia. That's always a good idea to do. And call all of this. Dex not defined. Oh yeah, it doesn't make sense to call run game here because we should first load the dex before we run something. And we should also deal the cards before we actually play. Run game. Player goes first not defined because I didn't define it here. So it's defined. Okay, this doesn't work. For some reason, the print line doesn't work. If debug, oh, because obviously here, down there, I don't call it. So here I should probably say true. And it still doesn't work for some reason. Debug is false. I give it a player goes first. And if debug, wait, let's print debug. And here I will run the game. Run game, 1, true. This works now because I have it in memory. It never prints the debug variable. Why is that the case? Let's print it up here. Print debug. Here it prints it. So here it works. Where no, not the deal cards, but this function. Here debug works. So while the deck, oh wait, is the deck length too short? That could be the case, so it just goes to the end. So we might have to deal the cards again to make it work. And let's copy these 2 lines. And so possibly the run game function just ended without having anything to play. False 2. Where does this false come from? It is here, this false. Because it's false. Why is it false? Didn't I put it to... Oh. So does this work? Oh, now I get it. Okay, it worked, but I was just being stupid. So debug flag works. We don't print the debug message. We just print player 1, player 2, 1 round 3. Okay, all of this works. So let's test now the alternative version, which I was sure of that worked, and it probably worked. I just didn't call the function in the right, in the right way. So let's test it again. Do all of this, do all of that. Deal cards, run game. Okay, it works. Player 2, player 1, player 2, player. So this works. The end thing did work. I was not doing the wrong thing. I was just calling it in the wrong place. So this works. We can do this in front of a print to get all the things printed that we want. So if, for example, we want this printed at the end, we can type it in here. And I will remove this testing code here again. And if I set this here to true, then we will see we get all the messages. And with the debug messages, for the 100,000 lines, oh, this will take forever. Let's cancel this. This is by pressing Control C, I can cancel this code. Let's do it only for 1,000 times. This takes 0.4 seconds if debug is true, and it takes 0.01 second if debug is false. So, and even if I run it again, because code optimization, because here it had to do some garbage collection, that's cleaning up memory, what this means. So if I do this again, it takes about 0.004 of a second. So printing to the console is very costly. It takes a lot of time. Make sure that if you print to the console that you have a way of disabling printing to the console if you want to run a simulation like this. And here we should end this relatively long video. In this video you've learned how to call functions, how to write functions, how to measure the performance of functions, how to make sure that you can run your code independently from one another. The actual run game is not fully independent because it doesn't take the DEX in. It takes the DEX from the global variable, which is accessing global variables is slow. So we could even improve this by putting the DEX command in here and giving it the DEX that it should play with. And that is maybe a short exercise that you can try. Put in the DEX variable here that it should make a copy of the DEX, or maybe you can, yeah, it should make a copy of the DEX and play with the DEX without accessing this global variable here, and measure how much faster your code is going to be. And this concludes this video. I hope you learned something, and we'll see each other in the next one.